All right, pre-algebra, we're going to start with our second way to solve systems. This is not from your book, so you're just going to have to take notes on your own. So go ahead and get a sheet of paper out and write some of these things down. There are unlimited amount of YouTube videos that you can look at, and you simply type in solving systems by substitution, and you're going to see all kinds of things. All right, so we learned how to graph the other day. We're going to do it algebraically now without graphing and get the same types of answers by using substitution. So the first thing you're going to need in step one is you have to have a variable by itself. So what I mean by that is it has to say x equals or a y equals. If it doesn't, then that's a whole nother story. You have to get that by itself before you can even begin. So if you look at this one, it's already set up. So that's step one. Solve one of the equations for either x or y. This one's already done. The next thing you're going to do is substitute the expression into the other equation and solve for that variable. So what I'm going to have the kids do, normally I would have them circle this, and I would go to the other equation and substitute it in place of the x in the other equation. So if x is equal to negative 2y, then you think of it as like substituting in a sport. The x is coming out of the game. It's going to go to the bench. It leaves. It just goes away. And in place of the x, you're going to replace it with a negative 2y. And then you're going to get an equation like this, and you're going to solve. Well, 3 times negative 2 is negative 6. And then you rewrite it all. And then you combine your like terms here, and then you divide and you get y. Once you know y, you go and you replace it back up into this circle. So if x is equal to negative 2 times y, and you just found y to be 4, then negative 2 times 4 is negative 8, so your x is negative 8. All right, so first step, make sure you have a letter by itself. Next step is to substitute it in, solve for one of the variables. Once you've solved for one of the variables, then you substitute it back into one of the originals and you check your answer. They're showing you how you check it. We did this with graphing. You're going to take negative 8, plug it here. You're going to take 4, plug it there. Does negative 8 equal negative 8? Yes, it does. Okay, etc. You don't have to do the checking, but it's definitely a good way to make sure it works. All right, so step one, do we have a letter by itself? Yes, we do. X is all alone, so I circle this 5, and I say, well, 5 goes into the x in the other equation. So x disappears, 5 comes in. So I'm going to rewrite this as 5 plus y is equal to 12. And then I'm going to solve for y, so I do that by subtracting a 5, subtract a 5, and you get y to equal 7. Well, if y is 7, x is 5, you're done with your answer. Okay, that was a pretty simple one. Okay, here, I'll just work on the back of this one. Okay, I'm just going to write out a few problems, and I'm going to show you how to solve this. So the first one I want you to write on your paper is x is equal to negative 2y. And then we're going to write x minus y is equal to 9. All right, so step number one, do we have a variable by itself? We do. It's this x. So you're going to circle this. This goes in place of the x. So x leaves. It goes away. This goes in its spot. So I'm going to rewrite it with the x out and negative 2y in its spot. So it would read negative 2y minus y equals 9. So you can see the x left, and this just went right in its spot, all right? So in your notes, maybe do something like that. That goes, and we get this. Now I'm going to combine like terms. Well, I have a negative 2y minus a 1y is negative 3y is equal to 9. Divide by negative 3, divide by a negative 3, and we get y to equal negative 3. All right, well, if y is negative 3, again, these are your notes, so take it, draw an arrow up here. X is equal to whatever negative 2 is times y, so negative 2 times a negative 3 is a positive 6. And there's where those two lines would intersect if we were to graph. And then by checking, this is what they meant. Take 6, put it here. Take negative 3 and put it here. Well, if you're minusing a negative, if you're subtracting a negative, that becomes a positive. So 6 plus 3 is equal to 9, and we know it works because we use the other one. Okay, let's try another one. Let's do y is equal to negative 3x, and we know that x plus y is equal to 4. Again, step 1, and all of these you'll have a letter by itself. So we have y by itself, so I'm going to circle this. This goes in place of the y because it's equal to the y, so the y goes out. Negative 3x comes in, so I'm going to rewrite this. There's my x. Y leaves, it goes in. Combine your like terms here. 1x plus a negative 3x is negative 2x. Divide both sides by negative 2. And you get x to equal negative 2. All right, so there's your x coordinate. Well, if x is negative 2, you're going to go plug it right here. Y is equal to whatever negative 3 times negative 2 is, which is 6. And then you can double check by plugging it in. Is negative 2 plus 6 4? Yes, and we know it works over there. All right, so let's see. Let's try one that maybe looks a little more, hold on a second, a little bit more complicated, but not bad. Okay, we're going to write this one out. So you got x equals 3y plus 1, and 2x plus 4y is equal to 12. All right, so still rule number 1, do we have a variable by itself? We do. We have that x alone. So you're going to circle this. Since it's x, x comes out. This goes in place of this x. So I'm going to rewrite this with this in its place. Now, because we have so much here, this is this 2, bring it down. I come to the x. I'm going to use a parenthesis. I'm going to replace it with this. Okay, we haven't really had to use a parenthesis before because we didn't have any numbers in front of the variable we're substituting in for. So you can visibly see that the x just got replaced with that. All right, so then plus 4y is equal to 12. All right, so not bad, just a little bit more math in here. So you're going to distribute the 2 across. 2 times 3 is 6y. 2 times 1 is 2. Plus 4y is equal to 12. All right, combining like terms here. 6y plus 4y is 10y. Plus 2 is equal to 12. Subtract your 2. You get 10y is equal to 10. Divide both sides by 10. And you get y to equal 1. All right, now that you have that, so that's your y of your ordered pair, you're going to take this 1 and you're going to put it right here and just do mental math. 3 times 1 is 3. 3 plus 1 is 4. So x is equal to 4. Just make sure when you write your ordered pair, because sometimes you're solving for x first, sometimes you're solving for y first. So just make sure when you write your ordered pair, it's always in the order of x, y. So since y was 1, make sure you put it here, and then when you plugged it in to get your x, it goes first. All right, so let me give you one to try on your own. So pause the video after you get it written down, and then check your answer with mine and see if you got it correct. All right, so first step, circle this. This goes in place of that y. All right, pause your video and try it on your own. Okay. All right, did you get the answer? So you plugged it in. We're going to distribute this -6. Now you have to be very careful. Give it 2 seconds. You're going to distribute your -6 across. Remember, 2 negatives make a positive. Combining your like terms here, you get -10x. I'm going to subtract my 24 over. Divide both sides by a negative, and a negative divided by negative is your positive, so there's your x. You're going to take that, plug it back up into your circle. 4 minus 4 is 0. All right, so double check your answer. If you missed it, there's your work. Go back through and check it, and your worksheet will be on Google Classroom.